Welcome you all. My subject for this semester, I will be dealing Big Data Analytics for 4th BTech CSE and IT, Department of CSE, Adikavinana University, Rajahmundry. Yes, yeah, this is what our subject for this semester. One of the subjects we are going to see in fourth semester, fourth year, first semester. Yeah, Big Data Analytics. It is very easy, very important, and a very demandable subject nowadays. Just in today's class, we will see the what is the title and the justification of this title. Here we can see, I can say that in this big data analytics, I can say that we have to study of what is analytics. Partially we know what is a data, and we should know about big data, and finally we should learn about big data analytics. And very fastly we will see what is data, which you already know, but just a brush up of what actually is a data is. As yes, the definitions previously, all this we say like something which exists, which has the information inside it, and which is a fact, which does not have any relationships when it exists as a data, and which is of different sizes. Yeah, it is like the thing which is an entity in the real world, which is an object in the real world. We can call that to be as a data. As we have studied previously, you have studied database management systems, you have seen data warehousing, you have seen data mining. All these things, they consider, they take the data to be as a key object. So one thing, the very specific thing we can say or tell or define about the data is which is the real thing in the world, which is the reality in the existing world. We cannot call anything which is assumed, which is presumed to be as a data. So we can say that data thing to be as which has done, which is a fact, which is a history, and coming to the secondary aspects of the data is, as we say, like we can say, we can take that data to be as a simple thing, we can take data to be as a complicated thing. Whether it is a simple data, whether it is a complicated data, as the data is residing, as the data is considered, though the very important information resides inside it, we cannot retrieve it properly unless it is given to some aspect of some tools. As we have studied, like when you are dealing with structured query language, which digs your data, which questions your data, which makes your data to uh, to be applicable to your questions and get the information out of it. So which means that the data exists there, but at the same time, to get the information out of it, we need to take the help of some tools. Now these tools, starting from structured query language, we do have a high range of data mining tools, warehousing tools, business analytic tools. Number of tools are there to utilize the data in a proper way. The final thing is, the final thing why we need to have an information, why we need to dig the data, why we need to process our data is just this information. With the information, people are trying to get a knowledge out of it. And again, as previously we have discussed in the warehousing and the data mining, why people needed knowledge, what is the use of that knowledge. By applying this knowledge, people would like to go for the decisions and predictions. So the final thing is, when we are going for people, and it's not only the knowledge, they need the knowledge as well as the wisdom. So here, after gaining the knowledge, applying this knowledge in a particular way the where this knowledge is applied in a right way, applying that process of applying the knowledge in the right way, that we call it as the wisdom. So people should know the knowledge, people should have the wisdom to utilize that knowledge in a proper way. So where all this is getting is the roots, nothing but the data. So this is what the minimum introduction of the data here, where the data is existing and it has hidden information, and again if we process the information we get the knowledge, and again if we process that knowledge we go for some analytics, and again if we process that analytics we get the knowledge as well as the wisdom and apply this knowledge to take the decisions. Yes, with a small introduction of this data, nowadays if we see, and if you observe or if you don't observe also, we are all the part of generating the data here. From morning till the time we sleep, from age 1 to age 90, from household to a big MNC or a big organization, everybody are being the part of generating the data, being the resources of the data. We ourselves are generating the data. And if you see, like, if you just for an example, if your mother sends you to a shop and asks you to get something, yes, you go and get and that one. And similarly, if your mother asks you to go again and again, ask you to get something, some other material or some groceries, and ask you to get, yes. So just if you go like this 3 days, and if you observe yourself what you have done the last 3 days, what your mother has asked to bring or get from the groceries, and if you see that, if you observe that data, you can finally end up by saying that yes, among the 3 days, these are the items frequently I purchased. Among these 3 days, I did not buy this particular item. Among these 3 days, this is the time my mother is asking to go and get me something. So this is the kind of the story related around the data. So the data here, there it is, you're going and getting the groceries from a particular shop. And if you see, and you can get lots of information out of that, is if you go to one shop where you don't find that particular item, you go to another shop. If you go to second day, if you go to the same shop, you did not find the item, you go to the another shop. Now you come to a conclusion that this particular shop does not have anything which my mother asks. So that is the information you can retrieve out of it, right? So these are the things where we can formulate, where we can have a storytelling behind the data. But these storytellings, these stories or the information behind the data nowadays are very more important, for very key aspects for any organization to develop, any organization to grow. These are the things what we need. Now if you see this one here, it's a simple aspect. I just started with the simple everyday thing, going to a grocery shop and getting something. But if you see the world around us, the organizations around us, the medical claims, your mobile data, I think this mobile data or the mobile information, I need not explain much for you, especially and if you see that almost by I think only when you are sleeping you are leaving your mobiles, but almost most of the time you are having mobiles in your hands. You are the generators, you are getting so much of data inside, you are giving the data outside. And non-retail outlets, just some consumer shops, hospitals, some softwares, your genome registers, optic genome registers is registries is nothing but it is a kind of medical data with respect to medical data only. And the patient registries, different organizations, government, pharmacy, all these things here, this is just one example of the medical thing. Again in this medical thing, different aspects of different types of data. This is only pertained to medical history. But if you take any organization, any bank, if you take any consumer shops, if you take any universities, everything will have different types of data. So nowadays, like, we cannot define what is not a data, right? Everything is data. So when we are considering this thing to be as data, everything to be as data, and since years we are studying database management systems, and since last 10-20 years we are studying data warehousing, and nowadays you hear the words data science, data mining, data analytics, data analysis, so many things with respect to the data. So no, we will just say, like, when we are coming to a point, or when we are confirming to a point of what is this data, and the subject what we are going to deal is big data analytics. When we are having a subject of big data analytics, you should get an idea of why big data analytics. Is there not a small data till now? Is there any average data? What is this? What might be a small data? When already small data is there, or something is there with respect to the data, why specifically, especially this big data, why we need to analyze this one? So though you have studied DBMS, though you have studied warehouse, now I remember, like, when I'm studying, when I'm teaching the warehouse for you, I have drawn some pictures on the blackboard by making that size of the database to be in larger size, if you remember. I never given you, besides that, I have given you database as a small thing, but I never specified that database to be as small data analytics. We did not go small data. I just referred that database to be a size lesser than the warehouse. It might be small, like that I have said. We did not go for the analytics. Does it mean that did we not analyze the small data? Yes, we have analyzed the small data also. We have the techniques, we have processed that small data also unknowingly, without knowing that term small data. It is nothing but querying your data. All of you might have written the queries in SQL. Yes, that is nothing but you are simply analyzing your small data. Because we have come across the definition of the big data, now we are saying that data to be as small, but we have already processed the data. We know the techniques how to retrieve the information out of it. We have analyzed that data. So simply, just by having that, what is this small data, just for example, if we know the data in a volume and format, that makes it accessible, informative, and actionable for everyday tasks. It is not only like everyday tasks, you can even have more than everyday tasks. You can even have a monthly data, you can even have a quarterly data. As and when your data size is becoming increased, from small you go to the average data or the medium data, and then you go to your big data. So we just have the introduction of, or the examples of, what is the small data. Excuse me. So nothing but your data which we can query, data which exists of everyday tasks. So if someone asks what are the transactions of SBI of today of so and so branch, yes, that is a small data. Someone asks what are the sales that are at Spencer's at so and so shop on so and so dates or for this particular week, yes, you can call it as a small data. And if you see that some baseball scores, you see that every day, I mean, like, if you have some IPL, everyday data will be there. Yes, that is the small data. Weather forecast of the next day based on last 2 days, yes, that is the small data. Everything which compacts your data in the small size, we can call that as the small data. And now, if you can make that small data grow in a bigger way by accumulating that in different forms, and in different sizes and in different uh, times, from small age to bigger times, that we call that as the big data. See, if you see that small data, generally it is like, we can call that as, it is very easy to get that small data, because I said like everyday data, it is very simple and easy. It's a kind of a normal database, easily attainable. It is like, if you take a small data, we need not even say from a database, we can even say that a small Excel sheet also, that also becomes your small data. And if you make it little bit bigger, we try to save that in a database, and we call that, because of the size, we call that to be as, yes, a database, a small database. We can keep the size of your data into database. Now, as you keep on accumulating this small data, and when you considering your data of different types, we call that to be as the data is becoming larger in size, we are trying to call that to be as big data. We will see the definition of what is that big data after a while, but before that we will see what are the sizes of the data. When we say that, as we know, like we started our data, we try to store our data starting from our registers. When we say that, we try to save our data from the bits to the bytes to the kilobytes. When we have so much of data starting from our bits and bytes, kilobytes to yottabytes, we have this much of range of the data. We just have a break of what we consider to be as up to what size we consider that to be as a small data, and from where we can consider that size of the data to be as bigger size of the data. If you see that, you might be knowing all these things. If you can see here, starting from bit and nibbles, bytes and kilobytes, we have ended up with yottabytes. See, this is all like how many bytes we are having, and this 10, see, if you take the terabyte here, 1024, that is 1 kilobyte gigabytes, and how many bytes they are coming. This is see, if you have the statistics here, I actually removed some of the slides. If you have the statistics, nowadays, you know how much of the data one person will be generating from an WhatsApp. It is like one single person, a normal, who is not that much active, who is not that much sending their files or receiving the files through WhatsApp, they themselves can have simple receiving, they themselves can have some simple 1 megabyte of data. They might be using that much of data. And if you see, if we consider, if we consolidate the WhatsApp data in your house, in your class, how much of data we might be generating. And if we take on the whole, from all the AP, from all the India, how much of Facebook data we might be using, how much of WhatsApp data we might be using, they might end up with saying that some sizes in yottabytes. So this is the sizes of data units, and we can have like, from where we can consider this to be as small, and from where this data to be as average, and the average or medium, and the big data. Now if you can see the table here, which I have just obtained from the Quora, I felt this as a good example here. So if you take this small data which is less than 10 GB, and where we can manage that with the Excel sheets, and if you have the medium size of the data from 10 GB to 1 terabyte, simply we can say that one single database. And the examples here, you are having some millions of web pages if it is a medium sized data, and some, if you take 10 GB, some thousands of sales of figures, or some number of pages, thousands of web pages you can say here. And whereas if you come to the big data here, the size of that is going to be more than 1 terabyte. So more than 1 terabyte of data is nothing but which starts from your petabytes of the data. So if you see this here, your petabyte is nothing but 1 kilo terabytes. So that is where you end up with by saying your big data, it starts from the petabytes. So the size of your data is nothing but here the huge amount of data, the petabytes of the data here. Now by considering that, we are saying that we have come across till now by saying that we do have we are generating so much of data, and we are saying that petabytes of that data, and we are, because of the size, we are saying that to be as big data. But that itself is not enough to define the big data. We have to consider different types of data. Like previously, when you say, you all might be having an idea of what is Excel, what does it contain. So if you take an Excel sheet, you know that some rows and columns will be there, and each row you can consider that to be as one record, and we have some number of records, and we say that that is nothing but that represents one small database. And similarly, if you take a database and where we say that we insert, or that database consists of some number of tables, and each table again comprises rows and columns, and where again it considers some records, and we do have some data, and we take the help of some management software to maintain that database. And if you take the examples of this, we say that these sheets or the tables here, they are like pertained to some particular columns, where these columns we define that each column to be as one particular data type, and that same data type everyone has to fill that. So which means that you have predefined what that rows to be are of, which means that if you take a table, that single particular row, the data what it should contain, we are defining what that data should be and what size that data should be of, right? So similarly here, but when we come across, when we say big data here, we cannot confine that to be as it should be of this particular type, then only we can analyze. Just an example, a well-known example to you all. Again, if I go with the WhatsApp data, where you do some shopping, where you browse, where you watch videos, where you upload your audios, different types of data, you make it utilize. You are being the generator of that data using the different types of that data. Now I would like to analyze that kind of data here. So which means that I would like to analyze the type of the data where that data now is not fixed to one particular column, is not fixed to one type. So I might have different types, I might have different sizes. So what can be the different types of data? So if you see this here, you can have the structured data, you can have the unstructured data, you can have the quasi-structured data, you can have the semi-structured data. Yes, yes, we will see the different types of data here. So as we see here on the screen, structured data, unstructured data, quasi-structured data, which is the new one, we will see what all these are, and semi-structured data. With the example what I have started, if you can see what is the structured data here, simple thing here, if you can see a table here, customer ID, order number, purchased code, or billed revenue, something which we have defined the customer ID here, and order number, purchased code, something where we say that these things should be of one data type. So some structure we are giving to this data here. So just the simple definition here, data that resides in a fixed field within the record or file is called structured data. And the general example which is given is the relational databases and the spreadsheets, the general example they give here. and this thing we retrieve or we get this data, or the data can be processed with the simple structured query language. And if you say, if you take the spreadsheets thing, just if you have the icons, if you have the tools to operate, we can process this data. So without much definition of what is structured data means, it is nothing but where it has some, it is confined to be of fixed size and fixed type and fixed format to store that data. So that we can call that to be as a structured data. And similarly, if you take the unstructured data, this is what we need to consider here. So the unstructured thing here is the simple examples. What you can see is the sizes of your graphic images, your videos, your streaming data, your web pages, your PDF files, your Word files, your emails. All these will be your unstructured data. Now, why we have to call this as unstructured data? Just the simple example. If you take a PDF file, say for example, so that PDF file, if I have to send one PDF file to you, in that PDF file, I can keep any number of images in that, or not only PDF, any Word file if you take, I can keep any number of text lines in that. I can keep an audio, I can keep a video, something like some files I can embed in that files. Say if you take a WhatsApp, when you're sending something, early morning you give text images, you will send the images, you will send some videos, audios, different types. So the unstructured data, when considering to be as a different types, as well we need to consider different sizes also. So which means when you are sending a PDF file, unless you specify that your PDF file should not exceed this much, anyone can send any size of the data, any size of the file. So even if you take the emails, in that emails where you say that you have the to and fro, from and to mail IDs, which is the fixed format you have to definitely give. But the body of that email is not fixed. You can send anything, that body of the email, the attachments, whether you attach or not, anything you can send. So these are the examples of unstructured data. So in this unstructured data, the main thing what you have to keep in mind is the size of the data is not limited, the type of the data is not limited, and the type of the data is of different types. So it is like anything can be your unstructured data. So this is the main thing, this unstructured data is the one where people are trying to analyze this kind of data nowadays. So we will see the quasi-structured and semi-structured, and then we'll combine all this. Again, we'll see the examples of this unstructured data types, the text files and the documents, your website and application logs, your images, your sensor data, your video files, your audio files, your emails, your social media data. All this comes into your unstructured data. And if you see this one example of your semi-structured data. So this semi-structured data is the one which you have to say that, which you can say that there will exist a format, and inside that format anyone can have of their own type, but they should fill according to that format. So if this is the university and the student ID, roll number 1 will give his roll number as 1 and roll number 2 can give his data as roll number 2. But he has to give what is his student ID. So which means that he cannot skip the student ID, but the value what he gives is unique. These are the types we call that to be as semi-structured. So in the semi-structured data, say this is simple kind of XML file. So in the XML file, you give a template, you give a frame, you give a format, but the values inside is up to you. This is what your semi-structured data. See the simple example here, one more semi-structured data here is one paper here. The what the paper should consist of as the heading of that paper, author should be there, his first name, his last name. This is the author's name, first and last, his main name, title, journal and the year. If you send this template, each and every author will have different names, different values here, but they have to fill what all these are. This is what is semi-structured data. Your semi-structured data, sometimes your XML sheets, your emails, they'll come into your semi-structured data. Email is an example for both. Like you can consider that to be as an unstructured data as long as you consider the body of that and as long as the format is considered, your email again comes into your semi-structured data. And if you take the unstructured data here, you can have anything of the any size. And if you take the structured data where it is pertained to the size and the type, where it's a kind of the relational table, we consider that to be as the structured data. And nowadays the new term what we are getting is quasi-structured data. Before we define that, the example of quasi-structured data is one type of data will get converted into the other type, into the consolidated type. Say if you see the clickstream data, which like hit level data, you take any example, if you take a Google website, and in that website, if you are a client ID, how many seconds you have used that page, from this page to what is the page out, what is the other page you have gone, what are the IP address of that, what is your session ID, how long you have spent on a single page, how long you have spent on that particular site. So all these things, these hits and all, if you can convert this quasi structured, again what you can say is quasi is a kind of unstructured, it comes into an unstructured erotic data where it is not usual, where it is not regular. That kind of data, if you can aggregate that, so which means that one day on a Google website you can sit on few seconds, the other day you can spend some hours on that Google website, where that time limit is not fixed here. And one day you will go to one website from that page and the other day you will go to another website from that page. So it is like erotic quasi structured data. And finally, if you consolidate all that for pulling up some number of days, so for the last 4 days, how many hits are there for this particular page, from this page what are the sites they have gone, how much time they have spent on this page, what are the IP addresses that have come from, which are connected to this page. All this kind of data, you call that to be as quasi structured data, and generally you consider that to be as a textual content. See, this is the example, like quasi-structured data is the data about web pages a user visited. Just one simple example, but any of this kind, any of your office, any of your organization, how long they are visiting that web page, who are the clients visiting that, who are the what are the market oriented deals they are coming up with. All this you can consider to be as quasi-structured data. So this is hope, I think you have come across, you have understood what is like, you have understood what is the data, what we are calling that to be as a small data, what is the big data, and the different types of data. So now you can say that your big data here, it is not only the size, you need to consider the type. Understand? So here if the data is of huge in size as well as your data is of different types, you call that to be as big data. This is again an informal. After we see the characteristics of that data, we will again define the actual term of what is big data here. So we will see the classification or the characteristics of big data here. If you take this simply general, like everyone we say that 3 V's define what is your big data, or somebody says 4 V's and somebody says 5 V's, and nowadays they are telling 6 V's. The basic thing, we just start with 3 V's here: volume, variety and velocity. We have seen this variety of data just now, like structured, unstructured, semi-structured, quasi-structured variety of your data, and your volume from terabytes, petabytes, zettabytes and yottabytes, all this data. And one thing which we did not see here is velocity of the data. What is the speed of the data it is being generated? What is the fastness of the data it is being generated? Actually, like old says, we say like we give the batch data for processing, and later we are giving the real time data, and now we even consider the streaming data. Streaming data, it's nothing but every nanoseconds also you consider the streaming data. So if you combine all these things, your velocity here, which is for starting from the seconds, your volume going till zettabytes and yottabytes, your variety having all different types of your data. All these, combining all these, you call that to be as big data. And there might be just one more, 2 to 3 more V's are there. Veracity data, value of that data, some things like this. Now if you see this here, we did not see what is this veracity, uncertainty here. Some data, whatever is given, we cannot blindly take that data. There might be some inconsistencies in that data. There might be false value in that data. There might be incompleteness in that data. So when you are considering your big data, you need to consider all this characteristic also: veracity of the data, how far the data what you are considering is reliable, what is the percentage of the data what you consider to analyze is reliable. That is what your veracity of the data. So whenever somebody wants, whenever somebody is considering the big data, you should have 4 or 5 questions to that. What is the size of that data? What is the speed of that data? What are the different types in that data? What is the certainty in that data? Whether it is trustable or not, whether it is worthy or not, whether it is reliable or not. So all these 4 V's you have to ask whenever you are considering a big data for analysis. So now we will see the simple examples in just a few minutes of what these 4 V's are. Just the volume of the data, collections, how much of data is getting connected. Just if you browse the statistica.com website, they will tell like how many Facebook users per day they are going, per year they are going, and country wise also they are giving. So not only this, hundreds of websites are there which gives the statistics of how much the data is getting generated and accumulated. So all this comes into the volume of the data. Just the percentages here, this percentages I have taken for 2018 data, and you can have the recent statistics also. Just the statistics of how much of the volume of data is being generated every day. And see, if you consider the velocity of the data here, for every 60 seconds, how many tweets are getting, what are the updates, your instant messages, Google searches, emails sent, data created, mobile web users. For every 60 seconds, how fast your data is getting increased. So this is what your velocity of the data. And if you consider this variety of the data, you have the emails, you have the chats, you have the audios, you have the videos, everything you consider that to be as your variety of the data. So veracity here, the veracity, we cannot guarantee that data, which is of some uncertainty existing in that data, but still you need to consider the data for analysis, which again comes into the big data category. So what we can say here is, like you can consider that your big data here, you have to say that if the data is consisting of four ways, or you can say that if the data is big in size, which is the volume, if the data is speed, which is like velocity, if the data is of different types, structured, unstructured and semi-structured, quasi-structured, which is the variety, and if the data is of consisting of inconsistencies, then we, and this kind or this type of data we call that to be as big data. So this is what actually is the big data, but your subject is big data analytics. This is what the actual thing we have to see. So what is this big data analytics here? So keep aside big data. Now we will just see what is the word, what is like analytics means. Simple examples. Previously also I said like if your friend is there and if he did not come to the college for continuously for 2 to 3 days when it is raining, so what you say is, next time when it rains, you have an idea whether your friend will come to the class or not. If somebody asks how come you can say like that, why your friend is not coming, you simply tell them that yes, according to my analysis he won't be coming because when it rained last time he did not come, so that is the reason he may not come this time also. The probability of whether he comes or not also you will tell. 80% he will not come, 20% he may come. So these are the things what you are predicting, what you are telling about your friend. Simple word what we generally use is, as per my analysis he will come, he won't come, this much percentage he won't be coming. So analysis is nothing but where you have the answers for some critical things. It may happen, it may not happen, but you give the answers, you predict something, you describe something, you tell something just because of you have the previous history. That is what your analysis is. So analysis is, or the overall thing, what you predict something, what you can describe something about this analytics. So here again the small difference here, we are studying big data analytics but we do have the analysis. Slight difference between analysis and analytics is, analysis is nothing but from beginning till the ending what you predict for the prediction, that is what your analysis is. So which means that you start from the beginning, you consider the data, you pre-process your data, you have the clean data, and then you query that data or put some techniques on that, and then retrieving the data in what way you want. All this is your analysis. Coming to the analytics, just the technical part of processing your data, the technical aspects of what you try to retrieve from that data is your analytics. Now, if you see the analytics, see, I'll give you the simple example is, the first example what I gave, when your mother asked you go and get you something from the shop and where you brought something. So here, the task which is given by your mother, you are doing, and the technical aspect of how you are going and getting that, whether you are going by a bicycle, whether you are going by a bike, whether you are walking and getting, what are the measurements what your mother has asked, whether you have purchased that same amounts or not. All these technical aspects will come into the analytics. So analytics is a kind where we try to question and get that one. So querying, the simple thing is the querying. So this querying here, you will have the simple queries. Starting from the simple queries, this querying will go to the complicated techniques. Complicated techniques are nothing but the algorithms. So that is what we will study in the analytics part. So the relation between here, it is like when you say big data, when you know what is the big data and what is the analytics is, we try to retrieve the information out of that big data. We try to retrieve what is hidden, what are the patterns hidden inside that big data, how well we can process that big data. Now the subject concerned here, what you are having here is big data analytics. What we will see in all the units is, the first unit is what is the big data, how we can process that big data, what is the architecture we need to process that big data. So that is what we will see in your first unit. And then what is the processing of your big data is nothing but getting the information out of it. So what is the optimal best way of processing your big data? What are the different techniques of that? What are the tools available in that? When we say a framework is there, which we are calling that as in Hadoop, but we are going to focus on the Spark to process that big data. When already Hadoop is there, why we have to go for the Spark data? What are the differences between them? Is there any advantage of going with the Spark, and what are the different algorithms we will be using? What is the code in Spark to process that big data? That all we will see in this subject. So what I can say is, we have seen what is the big data analytics title. I think and I hope you have understood at the end of this class what is the data, when we call that data to be as a big data, in what terms our data becomes a big data, what is analytics, what is big data analytics, what we are going to get by analyzing our big data, what for we are doing all this. So these are the questions. If you are having the answers for all these questions, next thing we can dive into the actual syllabus in the class from the next class. So I hope all of you have understood what we will study in this semester with respect to this subject, and the familiar terms we will see, and we have seen already previously with respect to the data mining. We will come across simple techniques which we have already seen, and the coding aspect and the analytics part, which is with Hadoop and Spark, we will see what all these are. In case if you have any questions, yes, let us have a WhatsApp group. You are welcome to post your questions in that, and at the end of every 3 to 4 classes I will give you one assignment which you have to submit. Maybe we can use the class marker for that, and any other doubts you can contact me. So just wait for the next video, we will see that, and we try to complete the syllabus as well as some other aspects which are new to this concept, we will see. Okay, thank you all.